Yeah, okay, let me share my screen. Yeah, so we're going to discuss today on the NLP related concepts along with some some ED analysis with matplotlib with coronavirus data sets. So these are some of the sample data sets we have taken from Kaggle only. So you can also, I will also share with this CSV files or some of the Excel files what we had. You can also practice well by using some of the matplotlibs. So we'll come this notebook again maybe. So let's go and understand some of the NLP related concepts with regarding the tokenization mechanisms. So tokenization is a process to convert from text to integer or text to a number. So what will happen? You can say. So I hope you know something related to the computer science. Computer will learn only the numbers, that is zeros and ones. It may not be learns any integers or any, it may not be learns any kind of the strings or any kind of the categorical values. So you have to convert from whatever the string formats or whatever the categorical formats to the numerical side. So that is the reason we need to convert any kind of the strings or any kind of the text you're going to be get from the data to the integer. So for this process, we can also call it as a tokenization. In that manner, we can also divide it with some of the other algorithm to utilize it. And what will happen if you tokenize the sentence? Suppose you have a sentence like this. This is this is a statement like that. You have a some sentence like this. So this sentence you want to convert to a numerical vector. So I hope you know, right? Something called as a vector we already learned in the 11th and 12th grade. It having some of the collection of the elements with corresponding to that. So what will happen when you have a sentence? It will divide it into a words. So this is a word. We can also call it as a some value for this. We can also assign to some value according to that. And the statement is also converted to some value. So like this is going to be divided as a three words. You can say as a sentence. We can also call it as a document for the NLP context. Document. So for all collection of the sentence, we can call it as a corpus. Collection of the sentence, we can call it as a corpus, and collection of the words, we can call it as a document. And we will get the we will get the words after completion of the tokenization, or you can say splitting of the sentences into the word. So these words can be converted into a vector. So if it is going to be converted into the one, the each and unique word, you can say each and unique word is going to be converted to some kind of the value assigned to that. So what are the different ways to assign a value? So that is also one question in your head. So we have so many techniques to do that. Something called as a bag of words, and something called as a TF-IDF, something called as a word to vec, average word to vec, and weighted average word to vec. So we have so many other methods like BERT model we can also use, that is most popular nowadays. So let's go and check out how does bag of words is going to be help us understand in terms of text to a integer. So bag of words, the concept is came from, we have a unique value, sorry, we have a unique records in your document corpus. So if you found any unique words, it's going to be converted into dimensionality vector by using the each and every word. So let's take this example maybe. So this car drives good and is expensive. This car is not expensive and drives good. So in this sentence, you can see this is coming two times for the both sentences. Car is coming from the two times. Is not there for the first sentence. Not is also not there. So whatever the unique words or whatever the common words you can say, so that will comes in a dictionary. You can see that will comes in a dictionary. It may not be repeat that again and again. So this is coming for once, car is coming from once, drives coming for once, good is coming from once, and is coming from once. Whatever the unique records or whatever the unique words we have from these two sentences, it's going to be divided like this, like a words in a list. Then how does it going to be create a vector? So that is other question, right? Just now we spoken about that. How does it going to be created as a vector, assigning each and every word to some value? So how does that going to be represented in the bag of words means every document is going to be created as a some dimensionality or a vector according to each and every word. What will happen if I assign some value to this, and what will happen if I assign value to car? So like that is going to be works out, and whenever you need some of the value around every dimensional, that is going to be equal to the number of occurrences of the unique word. If suppose this is coming from 2 times, the number of occurrences we have to give that according to the respective word. Similarly the car, similarly the drive, whatever the occurrences of the unique word, we have to prefer and give that value. So yeah, you can see like this is going to be get, you're going to be get for first word, we can say the first sentence is what we had. Yeah, you can see the first sentence, this car drives is expensive, this car is not expensive drive. That's going to be converted as a one vector, that is a v1, and secondly we're going to be converted as a second vector as a v2. So these vectors going to be represented like this in the, you can say, embedding matrices or embedding vectors to do any kind of modeling mechanisms or visualization things. So I can say bag of words is going to be helpful only whenever you have some of the words are occurring. So it may not be preserved, it may not be preserved something called as semantic meaning. That means if suppose I have a word like you can say some tasty, so tasty and delicious, delicious. So like this, I have a word tasty and delicious. These are the both words similar kind of the meaning, holding similar kind of the meaning, right? At my perspective, but as a system perspective, it may not be identified that. That means it may not be holding the semantic meaning. It will just allocating each and every word for some vector or some value according to that. If suppose I got a value for 1 for this, I got a value for 0 for this. So according to that, I get some values, but it may not be preserved. These two values or these two words are the same. So at the time, it may be confusion between the bag of words. So that is a major disadvantage with the bag of words. So we come over with other techniques to hand over the semantic meaning. So yeah, it will obviously compute some of the distance between the each and every word. Okay, between the each and every word, if you're going to be compute the distances, you will get whether it is coming, you can say whether it is coming near or forest far, then according to it's going to be give some value to that. So similarity wise, bag of words is better when compared to the semantic wise, it may not be helpful. So that is a major